class, and welcome to section 5.3, which is all about step functions. By the end of today's lesson, you will be able to graph and apply step functions. A step function is a very specific type of piecewise function where each portion of the graph looks like a step. So essentially what happens is our graph is going to look something like this, where we've got each section looks like the next step on a staircase, except for they're not actually connected. There's two types of step functions. The first is called the floor function. This is the step function where you are rounding down to the nearest integer. So the notation for this is either going to be f of x is equal to the floor of x. You might see the actual word, or f of x is equal to, we've got these brackets underneath x, which means round down. To the reverse of that, we have the ceiling function, which is saying take whatever number you have and round it up to the nearest integer. So again, you can see it in word notation, which I'm actually missing the x part there, so the ceiling of x, or we've got f of x is greater than, we've got these brackets going above x. So if we are looking at this on a graph, we need to be able to differentiate between whether it is a floor or a ceiling, because as you can see, both of these graphs look very similar. The difference between them is determining which direction the values are going. So if we look, for example, these ones, so we've always got our filled in dots on the integers. So if we plug in 1, we're going to round to 1. If we plug in 2, we're going to round to 2. Same thing would happen on the other graph. If we plug in 1, we round to 1. If we plug in 2, we're going to round to 2. So the closed dots are always on the integer values. The rest of the function is what determines if it is a floor or a ceiling. So for example, if I'm looking here and I'm at 1.5, it's telling me that the answer is 1. If I'm going from 1.5 to 1, that's rounding down. So this is an example of a floor function. So when you're looking at the graph, you're able to determine if it's floor or ceiling by picking out one point and testing it. We can test any point. I so happen to pick out 1.5, but we could have gone over here all the way over to 8.5, and if I look up, that's telling me that 8.5 would go to 8. Once again, rounding it down. So these are all floor functions. This is the graph of a floor function. So I'm going to go ahead and solve these problems. So it's saying f of negative 2.7. What that is saying is to go down to the nearest integer. So I go over 2.7, and going down rounds me down to negative 3. If I plug in 0, 0 is already an integer, so there's no rounding involved. It stays at 0. So if you have an integer in a floor or a ceiling function, nothing's going to change because we don't need to round. Then if I'm at 8, again, we're at the floor, so I'm rounding down. 8.1 is going to round me down to 8. Looking at this next one, we can test another point. Again, if I go over to 1.5 and I go up, now it's telling me that 1.5 goes to 2. So this is an example of the ceiling function. So again, you need to be able to pick out a point and test it to determine whether you're on the floor function or the ceiling function. So go ahead and evaluate these three values in the ceiling function on your own. So negative 7.2 rounds up to negative 7. 3 is an integer, so it stays put. And then 9.9, we're rounding that again, we're rounding it up, and that goes to 10. The other thing you might see is it is not necessarily going to be graphed. It might be in the function notation. So this is saying f of x is equal to the floor function. Again, those brackets on the bottom. So what it would say is that we're going to plug in 2.61 in the place of x. That is telling me to round it down. So my answer is going to be 2. In this second example, it's asking us for the ceiling function, the above brackets. So I'm at negative 5.4, and the integer above negative 5.4 is going to be negative 5. Go ahead and evaluate this last one on your own. When we plug it into the floor function, that means round down. So we've got negative 4 for our answer. The next thing that we're going to do with this is apply different types of step functions to more real-world examples. So students are planning a field trip. If there are 40 or fewer people, they're going to rent vans that hold 15 people. If they have more than 40 people, they're going to rent buses that hold 65 people. The function is shown below. So for this first part, it's saying below 40 or below people, we're going to take our vans and we're going to divide it by 15. We're using the ceiling function because you're going to need to round up to make sure that you have enough vans to fit everyone. The second part says, again, we're going to take and we're going to divide by 65 now because a bus can hold 65 people. Again, we're using a ceiling function because we have to round up to make sure all of the people have transportation. So now it's asking, what is the transportation for 412 people? So we need to look at our step functions as our piecewise function. And we have 412 people, so that puts us in this bottom chunk. So what I'm going to do is evaluate the ceiling of 412 people divided by 65. When I put that into the calculator, it's going to give me an answer of the ceiling of 6.33, and it keeps going. We really don't need the rest of the decimal because now all we have to do is round, and that's going to give us an answer with the ceiling of rounding up to 7. So that means for 412 people, they're going to need 7 buses. Go ahead and try this one on your own, finding the transportation for 40 people. Since 40 is the included in the upper part, we're going to go ahead and plug that into the top portion of our piecewise function. It's going to give me 2.6 repeating as a decimal. The ceiling of that means that we need 3 vans to transport everyone. One more example of application. Jamal and his brother are planning to rent a karaoke machine for their class event. The graph shows the rental cost. How much will they spend if they rent the machine from 8 a.m. to 7:30 p.m.? So what we're looking at here, on the X, our rental hours are going to be our piecewise function. So these X values are going to be what we have either going to the floor or to the ceiling. Now, once again, they give us the graph, so I'm just going to test at like 1.5 hours. It's going above. It's going a step above where it should be at. So this is going to be a ceiling function. So we have f of x, and we've got our 2 different pieces. It says for the first hour, it's $30. So that's $30 if x is equal to 1. That's what the cost is going to be for that first hour. Or excuse me, not equal to, less than or equal to 1, because they could rent it for a half an hour. The second part of our function says $10 an hour after 1 hour. So we've got 10, and then we're going to use the ceiling, because they're going to charge us for the full hour. So whether it's 1.5 hours or the full 2 hours, it's still going to give us that same cost. So the ceiling of x plus 30 for any hours greater than 1. So that's how we can write the function based off of our graph. Now it's saying they're going to rent the machine from 8 a.m. until 7:30 p.m. So that's going to give us a time of 11 and a half hours. That's going to put us into the second half of our piecewise function. So I'm going to plug in and I'm going to say 10 times the ceiling of 11 and a half plus 30. What that means is you've got to solve the ceiling part first. So treat that like parentheses, solve that first. So that's saying 11 and a half needs to be rounded up, which is going to give us 12. So we've got 10 times 12 plus 30, which gives us 120 plus 30, telling them that it will cost them $150 to rent that karaoke machine for the time that they need. Second part of the problem, the event has ended early, so Jamal could return the machine at 7:05 p.m. How much money would he save if he returned the machine at 7:05 p.m.? Go ahead and try this one on your own. 8 a.m. to 7:05 p.m. is 11.803 repeating hours. Plugging that into our piecewise function, the second part, we still round it up to 12. The cost is still $150, so he saves $0 by returning it early. If you have questions about this or anything else from the lesson, please let me know when you get to class.